Welcome to Mac Made Simple. Today we'll be continuing our theory lesson further with dissection 2.3, which is forces and equilibrium in a plane. So till now the forces that we were studying and calculating had a resultant vector, and that resultant vector had a magnitude. But what if the resultant is actually zero? In that case, what will we do? So for that case, the particle, if the resultant comes out to be zero, then the particle is said to be in equilibrium. So when the resultant of all forces acting on a particle is zero, the particle is in equilibrium. So for equilibrium, we have summation of all the forces equals to zero, and F we can write into components as Fx and Fy, and we can put the I cap and j cap vector to denote the direction. So all this is equal to 0. Then if we take the summation inside, then we get summation fx I cap plus summation fy j cap equals 0. So this implies if this is 0, then summation fx must be 0 and summation fy must be 0. Now this is the relation that we have to remember to solve equations. Now Newton's first law of motion. It states that if the resultant force acting on a particle is zero, the particle will remain at rest if originally at rest, or will move with a constant speed in a straight line if originally in motion. So that means for if a body is in equilibrium, then it will remain at its state of rest. If it is not moving at all, then it will remain at its state of rest. But if it's moving at a constant speed, then it will continue to move in that straight line. In that case, the particle is said to be in equilibrium. Now we will study what is free body diagram and space diagram. So this is a space diagram. A space diagram is a space diagram is a diagram in which all the weights and the pulleys and the supports are shown. But in a free body diagram, which I will be drawing here, free body diagram, we free the body of all of the components. We just are interested in the particle and the forces. So if in this example, a weight is connected to a line here, to C and then to A and then to B, then what would be its free body diagram? We will we will see first which point is in equilibrium. So the point C is in equilibrium. So we will put C here, and then on point C, there is a weight acting downward direction, and there are two strings attached. So they will be acting in this direction. So this is not the downward direction. I'll just draw a straight line. So this is the weight acting in the downward direction. This is another force, and this is another force. So we denote this tension by TCA. So because we all know that this weight is acting downward, so this force, this tension force would be acting in this direction. So we will write C first and then A. So that's why I have written TCA. Similarly, for this string, we will write TCB. So that's the free body diagram of this space. This is the space diagram, and this is the free body diagram. So that's all for today. In the next lecture, we will be solving some numericals. Till then, goodbye. If you have liked the video, please like the video and subscribe to my channel and share it among your friends. Thank you.